So let's just take a moment back and go to the very foundations, the very fundamentals of exponents. The topic exponents, which has some rules. This topic or this thing which I am going to tell you, the proof of what is 0 to the power 0, is very close to my heart, because first time when I saw this thing, I my mind was blown and I was completely shocked by the power of mathematics. And mathematics is great. Yeah. So let's start. So when I say that a number a to the power m, so what do I mean by that? What is this? So we all know that this is a into a into a into a, how many times? So this is m times. And so this is easy. So if I say that I am multiplying two numbers with the same base but different indices, so that will be a to the power m into a to the power n. So instead of just vaguely counting a into a into a, which will be m times, and again multiplying it by a into a into a, which will be n times, we have some rules which make our work a lot easier. So this will make our work a lot easier, which will be, the rule says that if we have two numbers with the same base but different indices, so we can just add the indices and write the base as it is. So this will be equal to m plus n, right? Yeah. And if we have, similarly, if we have the division symbol in between instead of multiplication, so if a raised to m divided by a raised to n, that will be a negative sign. So that will be just the base and the indices subtracted. Yeah. So but this is not commutative. So if you can't write it as n minus m instead of m minus n. Similarly, as we have learnt in the topic of integers, that division and subtraction are not commutative. Yeah. So let's just take a moment and see that and contemplate. So we all know that a number, say a, to the power 0 is always 1, and we also know that 0 to the power anything, so if we say 0 to the power 2, or 0 to the power 3, or let's say 0 to the power x, it will be 0. But what if we combine these two and say that what is 0 to the power 0? So what will be that? If you will put this in a calculator, it will show an error, because actually 0 to the power 0, the very basic idea of exponents is broken in this thing. So we have to find it in a different way. This way always excites me when I talk about it. So this is the way of limits. So we can find it by the way of limits. So I'll make a table here. Yeah. So this is a table, and let's say I have a function which is x raised to x, and the function is, if you are curious to know what the function looks like, it is somewhat like this. Yeah, this is not to scale, but it is not definable at x equals to 0. So it has a range of all real numbers except 0. So what if we could get very close to it as limit as x approaches 0 of this function. So what if we did that? Let's just put these mathematical terms and jargons aside, and I'll give you a task. So take out your calculator. You'll badly need a calculator, a traditional calculator for this thing, and I'll give you the x quantities and f of x. So this, if I give you x as 1, so the f of x will be 1 raised to 1, which is 1. Yeah, so the first x is 1. What is the answer? I want you all to interact with me with this video, even though I can't talk to you right now because I am a video talking to you, so I can't interact in real time with you. But try to pause the video and calculate yourself and have some ideas about that. So if I give you the first number, so that will be 1. So what will be f of x? So it will be 1 raised to 1, or 1 to the power 1, which will be 1. Let's go a little smaller. So I give you 0.9. So what is 0.9 raised to 0.9? You can use your calculator here. 0.909. Yeah. So what is 0.8 raised to 0.8? So it is 0.836. Oh, it is 8365. So I can write it as 837. That doesn't matter a lot, but I have to be precise. Yeah, I will need some more space here. So this is the space I am creating. Yeah, so sorry for that interruption. So what is 0.7 to the power 0.7? This will get a lot more exciting as you go forward. So 0.7 to the power 0.7 is 0.779. Yeah, so by this you can make some ideas, some preconceived ideas by looking at this. As you are examining, your mind can make some ideas about this. You can guess the quantity of this number, this exponent. So this exponential number, so you can guess where it is going. You may have an idea that it is constantly decreasing when the uh, 10 to the minus 1th power of this thing, the x is 8, it is also 8, this is 7, this is also 7, so it is constantly decreasing. So this function may tend to 0. You may have an idea that this function may tend to 0, but let's go forward. You will be surprised to see something that is very mind boggling or mind blowing. Yeah. So let's just have 0.6. So this is 0.736, and again 0.5. What is it? 0.707 and 0.4. This is 0.693. Yeah, so by now you may have some idea that, oh, the function is decreasing now, but it is decreasing with a smaller rate. So the slope of the function is also decreasing. So it is getting much more gentle. The slope here was very steep because the jump from here to here was a lot. It was 0.1 jump. For every 0.1 jump in x, there was a 0.1 jump in y. So but this time the slope is a lot more gentle, so the derivative, we can say, is a lot less than the previous times. So let's go ahead and let's not talk more about it, because again you are going to be surprised by this. Let's go ahead. So again I'm drawing this table. Yeah, so I give you 0.3. Let's go more deep into it. So as you see here, for 0.3, have you calculated it? It is 0.696. So sorry, it is 0.697, because it is 0.6968. Yeah, so till three significant digits it is 0.697. But as you see, from here to here, it has started increasing now. So maths is unpredictable. It is actually predictable, but you can't say anything before you know what is going on here. So let's just go more deep. It was decreasing, and then its decrease speed reduced, and then now it has started increasing. So but the increase rate is a lot less, because it has just gone from 0.003 to 0.007. Yeah, so that is just an increase of 0.004. But let's go ahead. I have changed my color. Let me give a more colorful design to it, so that it excites you more. So this is going to 0.4. What oh, I have written 0.4, sorry, that is by mistake. Yeah, so we must go to 0.2. So what is 0.2 raised to 0.2? It is 0.7247. So 0.725. Yeah, it is 0.725. Now it has started increasing rapidly, so the slope is going up again. Yeah, so the slope is positive basically now. And sorry, it is negative, because we are also going down from the x direction, so that was a mindless mistake. And the slope is negative again. Earlier it was positive, because as we were going on the negative side of the x-axis, we were having an increase in the values of y. So let's just do it. 0.1. So what is 0.1 raised to 0.1? It is 0.7943. So it is 0.794. So as you can see, the values are increasing rapidly now. Let's go deeper into it. So let's just increase the accuracy of that. So 0.009. Sorry, 0.09. Yeah, so what is 0.09 raised to 0.09? That will be 0.8.805. Yeah, what is 0.8.08? It is 0.817. So as you can see, the numbers are again increasing rapidly as we are going down the line. Let's just jump now to 0.001. So as we are putting 0.001 raised to, yeah, so as we are putting 0.001 raised to 0.001, so it is giving us 0.993. Okay, so now it is pretty predictable, but let's just go more to self check ourselves. So by going more into the precision of that, we can maybe solve for that. and let's take 0.0001. So what will be that? It My calculator is showing 0.999. Now you are getting me. So the number is approaching 1. So the limit as x approaches 0, the of f of x, when f of x is x raised to x is approaching 1. Yeah. So some calculators have less precision, so they can't calculate numbers with the orders of like precision of 10 raised to minus 6 or 7. They have maximum to that. So if you put 10 raised to minus 7 to the power 10 raised to minus 7, so that will, the calculator will automatically approximate it and give you the answer, which will be 1. So if you will put the very small numbers like 10 raised to minus 15 raised to 10 raised to minus 15, this is an index into an index. That is an amazing thing again. So your calculator will show you 1. That was an amazing phenomenon of mathematics. We solved it through limits, and this is what we got. So now you know one more fact in mathematics, that 0 to the power 0 is always 1. And how do you find it? Because calculators say it is an error, but you can find it by limits, because you have seen this video.